Okay, my name is Sean Newsom. My company is Shortbreak Tech, based here in San Diego. I'm a TMA BlueTech board member, former nuclear reactor operator on Trident submarines, waterman. I've known two of the three guys here for years and years. And I'm not an expert in renewables, but I am an expert in unmanned systems and sensors. So this is a really near and dear topic to me. I did some research for this because I felt like I had to know something about renewables, and I looked at Global Market Insights, and the wind energy market is got a compound annual growth rate of 15% between 2020 and 2027, from 23 billion to 97 billion. So as a robot sales guy and consultant, I probably should start paying attention to this a little bit more, right? So I thought that was a really interesting stat. I looked at McKinsey, and between 2020 and 2050, the Asia Pacific market is expected to grow 12 to 16% to a total of 820 gigawatts of energy, with more than half of that being the Chinese. Europe, Middle East, and Asia, 7 to 9% to 320 gigawatts in 2050. And us Americans, 9 to 13%, maybe getting to 100 gigawatts by 2050. So we're lagging a little behind. But on NPR this morning, when I was waking up, they said there was 40 gigawatts in the pipeline. Just happened to be a windshore discussion or offshore wind discussion this morning on the internet. So for those who don't know, physically these turbines, they are generally fixed mounted to a big foundation on the bottom in 50 meters or less of water. But as we progress with technology, now they're able to go 1,000 meters or more with a floating turbine that's moored with cables to the bottom. So that introduces completely different inspection requirements. I mean, I can go out in a kayak and do a 50-meter wind turbine inspection, at least below the water line. The other interesting thing about wind turbine inspections is you got all the way to the blade tip, and then you've got this air-water interface, and then you got to go down below subsea. So you're looking at aerial vehicles, you're looking at unmanned surface vessels, you're looking at remotely operated vehicles, you're looking at autonomous underwater vehicles. So, I mean, there's an opportunity to build wedding cakes of unmanned systems with sensors to autonomously do that. And there's actually companies that are doing that now. And I wanted to talk also about Ocean Power Technologies brought up wave energy, and I've been working with a wave energy company supplying elastomeric mooring systems for them. And they can sit proudly or hide stealthily and charge unmanned systems. So rather than have to have a whole bunch of survey vessels out there with 30 people on them at $125,000 a day, you could have one of these at each one of your jackup rigs and have it being run remotely. So think about the cost savings there. I got a really good panel here today. Dave Gentle, Shayan Haque, and Michael Jones. They're going to talk about their robots and sensors and present their capabilities, provide some case studies, and discuss some of the barriers to getting unmanned systems and sensors into this market in terms of inspection. So I'm going to give each presenter about 10 minutes. They're going to give you a little presentation. I'm going to introduce them first. We're going to go in alphabetical order because that's the way Michael Jones likes it, and I get it. And then we're going to open it up for questions, and I want you guys to ask us questions. We've got those prepared questions, but we really want to hear from the audience, okay? So if you can, entertain us with a couple questions at the end, it'd be really appreciated. So first off, we have Dave Gentle. Dave spent more than enough time on survey vessels, supporting software systems and survey equipment before moving into operations and commercial roles in the energy industry. He now works with Argeo, who are focused on offshore survey and inspection using autonomous and uncrewed vehicles. That's a new term, uncrewed, I like it. And is responsible for addressing the North American market. So let's welcome Dave and let him do his presentation.
Okay, thank you, Sean, for the intro. I got this one, I think. Yeah. So as Sean mentioned, Argeo, we are in the offshore survey inspection space, and we do that with autonomous underwater vehicles and uncrewed surface vehicles. So I'm just going to go through a few slides here and pick out a few items in the slides which I think are relevant for this panel here. So Argeo's mission. So we have built up over the last few years quite a capable fleet of underwater vehicles, which we'll go through some of those, and surface vehicles. So we've got the robotic solutions, and we also have our own crews, which we put out with those vehicles as well. Not on this slide here, and actually just recently we acquired a very capable crewed vessel. We're going to talk about autonomous vessels here, unmanned vessels, but to get those out in the deep oceans are some of the areas we need to put them out autonomously. We need these surface vessels to launch them as well. So we actually have the surface vessel as well. So we have the crews, we have the vehicles, but also what Argeo does is create. We have an R&D team, and we build sensors that go into these vehicles, which address certain operational requirements that we need to address outside the sensors we can get from the industry. And lastly, the other thing that we have is our data processing and analysis platform, which also serves as a data delivery portal for our clients as well. And that all rolls up to collecting the survey data faster with a lower environmental footprint and a lower cost for our clients. And I would add to that as well with a focus on HSE and Q, which we've got a lot of experience in as well. So the market sectors we're involved in, renewables, obviously we'll talk about that. Oil and gas is a sector. There are quite a few people in our company who have come from the oil and gas sector. So again, we know how to go out there and collect data in the ocean environment. Marine minerals is something that's also very relevant for us. We do have very deep rated vehicles in the marine mineral environment. In order to do the exploration phase there, we need to get down deep so we can understand the environmental situation on the seabed, but also the mineral potential. So that's something that's relevant. And then offshore construction as well is something that we're involved in. Earlier this year, we had one of our Sea Raptor vehicles survey the suction anchor locations for one of the world's longest bridges, and that's in Norway. So that's relevant for floating wind as well. So how do we do this? What do we actually do in those sectors? Well, survey is a core piece of that. So I'm talking about survey of the seabed, but also the near subsurface as well. We also are quite active in the inspection space. Some of our sensors we're developing in the EM area, which I'll talk about, very relevant for things like pipeline cathodic protection, which takes us into the maintenance space in offshore operations. And then we are also very interested in pulling that into some unique data models that have worked quite well in other industries, such as oil and gas, around data collection and data delivery, kind of multi-client type model or a speculative acquisition model, and delivering that as data as a service. So that's all part of what we do as well. A little bit about the vehicles. Just quickly here, you can read most of that for yourself. We have 2 Teledyne Sea Raptor vehicles, 6,000 meter capable. We are working with Teledyne on modifying these for some of our own specific requirements. An example there is lengthening the endurance to 240 hours, which is quite significant, and that's something we're working on for next year. We also have Hugin vehicles, 1,000 meter vehicle and a 6,000 meter vehicle, and we're developing our own uncrewed surface vehicles, our own USV. That vehicle is 9 meters long. You can put it in a container and ship it anywhere around the world, put it on a vessel of opportunity, and is very capable from the point of view of you can put almost any survey sensor setup you like on it. The other thing that we can do with that vessel is deploy an ROV. Now, we're not specifically in the ROV business right now, but it's certainly an option both on our crewed vessel and something that I think is potentially very interesting for the future. And it falls into the inspection space, is putting a mini electric ROV on the USV as well. So a number of different options there. A little bit more on the USV. This was developed and launched in June this year, and it's currently on a survey in Norway. That's collecting multi-beam echo sounder and sub-bottom profile data. And right now it's quite close to the shore, but it's important to note that this is actually quite a large vessel for a USV, but it is completely uncrewed and it's over the horizon capable. We're demonstrating some of that capability right now by having our operations team sitting in the office in Norway controlling that survey that's taking place in Norway. So good demonstration of that capability. So I'd like to go through a couple of examples that are relevant to this panel and this conversation. And this one is around really a business model rather than technology. So in summer here, what we did is we acquired one of these multi-client surveys. And again, what this is us going out and collecting data in an area of interest to our end user clients, and then collecting all of the data that a group of clients might want, and then processing that ourselves and making it available through data as a service model. So what we did here is in the Utsira Nord offshore wind area, offshore Norway, we collected a pilot study multi-client data set to demonstrate that this data can be collected and then processed to different resolutions in different areas. So that is available, and we're showing that at the moment. And a nice little example of this is here. This was an image captured by the Sea Raptor AUV, running about 20 meters above the seabed. It's apparently late 1800s, early 1900s sailing ship. Don't know much more about it, but as you can see, it's captured this vessel, which was right in the middle of the wind park. And if you look forward to how that could impact operations on any wind farm being developed anywhere around the world, then you obviously need to know about things like this. So it's just a nice little example of unexpectedly what we found on just that small little pilot area. Thanks. Another example here is from our R&D group looking at the EM sensors. And what they've done here is, I think it's really neat. They've integrated, I should say, EM sources and receivers into the AUV. And this is a non-trivial thing to do. Having the EM transmitters in the profile of the AUV and also the sensors, and having them built in without interfering with any of the very sensitive electronics in that vehicle is quite a unique thing. And this can be used for lots of different applications. Pipeline inspection in the oil and gas industry, where you're looking at cathodic protection surveys. We've also got some algorithmic smarts in there which will automatically track the pipeline or cable. And then I think what's really relevant to what's going on in California in the future here is tracking and looking at depth of burial for unpowered electric cables. And doing that with an AUV, we can do that much faster than current methods. And with the setup we've got here, we can look at deeper depth of burial with more tolerance in the cross-line position than is currently available as well. So that's something we're working on. We've modeled that, and we think that's going to be something that we can do in the near future. And the passive EM capability is what we've got currently. And lastly here, last slide, just like to mention briefly the software platform that we have internally. And we use this for our data processing offshore, the analysis, and display of the data. And we really have this so we can integrate lots of different data sets, ours included and others, and then use that as a collaboration tool for delivery to the customer. And we can deliver that as software as a service or data as a service. So that's something we're working on as a delivery mechanism. And that kind of rolls back to what Argeo does, which is really utilize all this technology in vehicles to deliver data to our customers. That is it.
Excellent job, Dave.
Thank you.
I could be way off, but I think there's probably only 3 companies in the world that have Sea Raptors and Hugins. That's a pretty impressive inventory. All right, next we have Shayan Haque. Shayan's business development manager at Exblue North America, one of my favorite companies, just because of how sexy their products are and the marketing looks good. He's leading the growth efforts in the U.S. on offshore renewable space. For the past several years, Shayan has been involved with the deployment and integration of Exblue's autonomous uncrewed vehicles, remotely operated towed vehicles, and other geophysical and marine biomass survey solutions for wind farm projects, as well as other marine geophysical and fisheries assessment applications. He's a graduate of Tufts University and being based in Boston for the past 20 years, Shayan couldn't be happier than to see the growth of the blue economy and offshore renewable sector in the U.S. He's passionate about promoting solutions that are safe, reliable, and eco-friendly, ones that help. That sounds good.
Good afternoon, everyone. I'm Shayan Haque, Business Development Manager with Exblue. Really thrilled to be here after 2 years of not being able to come here at BlueTech. This is kind of where it all started for us 5 years ago, so we'll talk about that a little bit later. Just a quick word about who we are and what we do. We're a French high-tech technology developer. We develop solutions in the photonics, maritime autonomy, and navigation solutions. Today, I'll focus primarily on our maritime autonomy space and the solutions that we have to offer for that. We started about 40 years ago in the industry, started mostly in the oil and gas and the maritime world, developing navigation systems, and since then we have evolved and expanded into other markets, mostly due to the core technology that we developed, which is a 3-axis fiber optic gyro compass. That's kind of where we started, and then over time, we started getting into shipbuilding and autonomous platforms, et cetera. So that's pretty much what I will be speaking about today. We're about 750 people globally. We have 8 industrial locations throughout France. We manufacture and develop everything ourselves, starting from the raw materials. We make our own fibers, as well as we develop and design our own vessels and USVs, et cetera. So we actually own and control the full vertical chain of production, and we build everything in-house. We have 12 global offices, including 2 in the US, and in the US, our focus is pretty much same. What we do is geosciences, maritime autonomy, defense. This slide kind of, to me, sums up all the sensors that we offer that are being used in the renewable space. So I'll kind of start from the top. We develop surface vessel navigation systems, inertial navigation systems, and gyro compasses, again, based on our 3-axis FOSS technology that we developed. And we also develop the same capability for underwater vehicles, AUVs, ROVs, towed sonar platforms, et cetera. That's kind of what you see on the Octane Nano OEM. We also have a full line of acoustic and sonar solutions. So acoustic positioning for offshore construction, subsea navigation, as well as sonar imaging, sub-bottom profilers, synthetic aperture sonars, et cetera. So all of this kind of gives like a full solution for either geophysical survey, pre-construction survey, development survey for offshore wind farm construction. But we have also developed a full capability called X Autonomy that's on supervised autonomy. So that involves USVs. So what you see over here, it's called DRIX, and what you see here, it's an 8-meter vessel, but we have a full line of other sizes as well that meets different operational envelopes. So for example, different speeds, different endurances, operating in different sea states, and as well as sensor payload capacity. We also have developed a full software framework around that's based on artificial intelligence. So that includes obstacle avoidance, data management, data fusion, all the time keeping a human in the loop. And recently, we have launched a ROTV, a remotely operated towed vehicle. That's an active wing, positively buoyant towed platform It can be towed from a USV like the Drix, or it can be towed from any other traditional vessel. What it does, it allows to expand the sensor payload capability. And this is something that we developed working closely with a wind farm developer who wanted this type of capability. You can integrate a side scan sonar and up to 4 mags on the wing. It can go down to about 2 meters to the seabed. Right now, it has been operated up to 75-meter water depths. And the restriction is not so much on its operational capability. It's mostly on towing the rope from the Drix as it stands currently. So between having a multi-beam and a sub-bottom in a Drix, and then having side scan and mag on this platform, we're able to do the full geophysical spread autonomously at about 6 knots. And then around that, we have also developed launch and recovery systems, as well as other survey launches for day survey or week survey. I wanted to show this slide real quickly because this is an actual project that one of our clients did. This just was completed in July. This is in the Saint-Nazaire wind farm off the coast of France. The Drix was commissioned to survey 80 monopiles. This video, though hazy, this is an actual footage from the Drix camera, and I think you can see how close it gets to an installed monopile. So the objective was to do bathymetric survey around 80 of the installed monopiles, and then do some pre-survey on areas where the monopile has not yet been installed. And this work particularly is important because the entire work was done within 40 hours in a 24-hour operation, completely remotely over the horizon from our remote control center in France. There was no human in the vicinity. There was actually no intervention vessel required to do this project. The intervention vessel was actually in the harbor. And it's also a very busy area because it's an actual construction site. So there were other vessels coming and going. So the Drix was operating remotely in a very busy environment over the horizon. So this is a project that one of our clients did back in July, and you can see some of the operating conditions in terms of sea state and being able to work 20 meters from the monopile. This is just a quick reference to other projects that we have done. So the Drix has been involved for the last 5 years in different types of survey, monopile bathymetric survey, inter-array cable route survey, export cable survey, bathymetric surveys, seabed classification. So these are some of the examples and some of the wind farms that we have operated in Europe so far. We also have a technology on sonar. It's a 3D volumetric sonar that was developed many years ago for fisheries application. It actually has a quite extensive use in Alaska and also in Canada in large fishing trawlers, looking at cod population, mackerel, etc. But it's basically measuring the water column up to 400 meters. So we have essentially adapted the technology for offshore wind farm construction because it essentially provides static bathymetry imaging for jackup rigs, for example. This is something that we have worked with a company in Asia. It can also be used for shark monitoring, whale monitoring, although not used in the US right now for reasons that I'm sure you all know. But it can detect marine mammals from a certain range. So along those lines, we actually did a collaboration with NOAA Fisheries, the New England Fisheries Science Center, last year at the Block Island Wind Farm. So they installed this, it's called CPIX. It's a 3D volumetric sonar, as I mentioned. They conducted this survey at the Block Island Wind Farm looking for pelagic species in a construction site. The idea being they're trying to understand what is the effect of construction on fisheries and aquaculture and biomass. So they actually wrote a paper that was presented at ICES earlier this year. It was done by NOAA. Thank you. That was my last slide.
Excellent time. Very cool technologies. Okay, now the man who needs no introduction. Michael Jones, co-founder and managing partner of San Diego-based Subsea Sail. They're developing a patented autonomous 100% energy harvesting long-duration vessel with unique sensors. Michael received his undergraduate degree from the University of Arizona in '73, having spent his junior year in Freiburg, Germany, earned a master's degree from Johns Hopkins University at the School of Advanced International Studies in '77. Michael's an angel investor, ex officio board member of the Maritime Museum of San Diego, and a board chair for the TMA BlueTech. He's sat on a number of board of directors, including one American stock exchange company. Michael's traveled extensively and can defend himself in 5 languages.
Okay, well, I'm the last speaker between you and the drinks, and thank you to Norwegian Embassy for hosting us, and thank you all for being here until late afternoon. So this is a real vehicle that we sold a couple of years ago to the U.S. Army Corps of Engineers. And you can go to the next slide. Oh, I can go next slide, can't I? All right. So the need is to create, we think, very affordable, long duration observation and cargo vessels. So we are trying to create essentially the CubeSat of the ocean. So going from billion-dollar satellites to $100,000 satellites so that we can literally sell tens of thousands of vehicles. And likewise, trying to create a different way of doing cargo. So we've moved away from a traditional monohull to 2 different kinds of vessels, and I'll try and explain those. We're really an IP shop that has developed a lot of technology and is now creating products. So our mission is to develop affordable, easy to deploy, long duration, submerging vessels. Everything we make has to be able to submerge, which has a lot of advantages. Our wing sail is hollow. That's the only way we could go underwater. We are disruptively economical compared to anything else that we are aware of. We have a minimal signature, so we don't have an acoustic signature, we have no heat signature, we have no radar signature, and we have a see-through sail. So you get out 50 meters and you barely see us. We've done all the things wrong that a small company should do, which means we have 3 lines of business. One is the observation vessel, which we call Horus, after the ancient Egyptian god of the sky. And then we have a multi-hull cargo vessel we call Hermes, after that famous Greek wind god who is also the god of commerce. And then we're creating unique sensors because we found that there weren't a lot of low swaps, size, weight, and power sensors. So we have 3 lines of business. Crazy, right? We have 5 issued US patents. We have 5 US patents pending. We have patents pending in Australia and Europe to do some of the crazy things that we are doing. We've gotten 3 Small Business Innovation Research grants, and I'm going to, the 2 from the Department of Energy that I will end up with to talk about how we work with offshore renewable energy. This is just to show how stable our vehicle is. Now this vehicle is 32 kilos, so 70 pounds. So it's very easy to put in the water. And so it's very affordable, easy to put in the water. It's got lots of capabilities. And we were out in 31 knots of sustained winds, 35 knots of gusts, and we were sailing at 1.4 knots. Now that's NATO Sea State 6, and NATO had an RFI out, request for information, looking for a vessel that could sail in Sea State 4, that could survive Sea State 5, and here we were sailing in Sea State 6. We can work in very low wind because we're a very light vehicle, but we are very upright in the water column, and we can work in very high seas. Why is submerging interesting? Because it'll allow us to hide from bad weather and bad actors, and with climate change, there's going to be a lot more problems. And I just read yesterday about a vessel that disappeared out in Asia. So there'll be more storms, more violent storms, and we need to figure out how to deal with that. So our vehicles will hide from bad actor and weather, but also to listen and monitor underwater. And that's one of the reasons we've gotten the funding from the Department of Energy. Our vehicles are perfect for combating IUU, finding submersible vessels and go fast. We have worked with a company called Applied Ocean Sciences. Our vehicle is essentially an edge computer. So we're trying to pick up data and turn it into actionable information. So we can reduce the amount of communication that's required. Everything is being processed on board. So we put a lot of processing power in a 32 kilo vehicle, including for acoustics. So you see an array, and over break, I'll be happy to tell you why what we're doing saves a huge amount of processing power. So this vehicle can do beam forming. and classifying right on board. Nobody's ever been able to do that in a small vehicle like this before. This just shows how easy to put in the water. This is one of my guys and the captain of our vessel, literally putting it over the side of a rib. We don't need special handling. We don't need an A-frame. We don't need a big container to move it. We've made something that's highly movable. We say, Horus is easy to deploy, but it's almost impossible. Look at the lower left. It's almost possible to find. We put 3 GPSs on this. So if you want to go out and surveil something, this is a kind of vehicle that can help you to do that in a way it's hard to find. And we'll be able to go below water if they happen to find us as well. So these are my last 2 slides. I don't know why there's a line through it, but we received a DOE, Department of Energy, Phase 1 grant, and that was to design a vehicle, to take our base vehicle and make sure that we could go down to 30 meters and that we were going to put a magnetometer on it. And so we did all that work in the Phase 1. And then for the Phase 2, we realized that underwater, to understand what's going on for offshore renewable energy, whether it's wind energy or it's hydrokinetic energy, these will be creating electromagnetic field. And it's very expensive to go out. We all know that with vessels. But with our vehicle, we can go out for months at a time. And so we're working with Pac Wave up in the Pacific Northwest in Oregon. They're a subcontractor for us. And we'll be putting this vessel out so that we can do like 6 months of baseline measurement of what's going on around the offshore renewable energy. And then as we realize that marine life reacts to magnetics, we all know that birds don't fly around with compasses, so they literally use magnetics from the Earth to move somewhere. Likewise, underwater, certainly marine mammals use Earth's magnetics. Some use the E field, so the electric field, and some use both. And so what we're finding is that people aren't doing a good job of measuring that. And one of my concerns is 5 years from now, let's just say someone comes along and says, my gosh, there's all this electromagnetic field. That probably came from your device that you put in the water. But it probably was there before because the Earth has electromagnetic field. But unless we do baseline testing, which is quite expensive to do, unless you do it over a long period of time and then you know what you've got, you run that risk down the road. And then we're not doing hydrographic work the way that the Drix is doing, which is a fabulous product as far as I'm concerned. We're trying to do long-range passive acoustic monitoring and measurements because we are a long-duration, slow vehicle. That means we have no flow noise over our acoustics. So we are now doing, we've just gotten 1.15 million to create a vehicle that can go down to 30 meters in the first year and then to 100 meters in the second year. And the reason to get down to 100 meters is to be below the thermocline. So this will be a very affordable vehicle. And yesterday I was talking with the Japanese professor who was here, and he said, my gosh, at that price, I could put them out every 5 kilometers, So people don't think about buying 1 or 2. They think about buying really fleets of these. We also are putting a mast stack on the top, which will have a color camera, GNSS, so GPS plus, and red over green lights. So we'll have navigational lights and anemometer, which we don't need for knowing where we're going, but is very useful if you want to be a weather station. So all of our vehicles will have classifying above water with video and acoustics below water. And then they'll be able to communicate via satellite, cellular, and Wi-Fi. So anyway, we're trying hard to create very affordable vehicles. We look at our multi-hull vehicle, which I'm not going to talk about here, as the FedEx of the ocean. And this is my last slide. We were in a tank in June. There's a 2 million liter tank here, and we were submerging. Every other vehicle that submerges uses forward motion. We have a patent pending on how to go straight down and just float, which means we can listen really well. So our result is a unique, patented, multi-use, highly affordable vessel to listen, monitor, and classify above and below water. And we're looking for energy development firms, environmental engineering firms, and service providers. So any of you are interested, love to talk to you. Thanks.
Perfect. All right, thank you, Michael. Did I turn this off? Well, I guess I can come over here. Thank you very much, Michael. Subsea Sail, I've actually watched it submerge in actual salt water in the Gulf. So it's been there, done that. So it's a really cool technology. I'm going to open it up for questions. I'm hoping somebody has a good question here to ask these guys. Some of them traveled far. They've got, they're hoping to hear from you, so show some interest in what they've been talking about. All right.
I've got. You didn't show a picture of it. You said you had a cargo one you're working on. How big a cargo are you talking about? I mean, it's meant
The
to
question
carry
is, how big could the cargo be? I don't know if that's on or not. So how scalable is the cargo version of Subsea Sail?
So that vehicle with acoustic array, with processing, with the weather station is $100,000. You know, compared to $1 million and above on almost every other vehicle. I'm talking about the vehicle I just showed. Our Hermes vehicle, which is our multi-hull vehicle, this vehicle will go about a half a knot to 2.5 knots. Again, there's an advantage to going slow because it helps you with the acoustics. But with Hermes, it's a trimaran, and we have a patent pending. The problem with multi-hull vehicles is they flip, which is why people don't usually use them for cargo. But we have a patent pending on if it flips, then it will right itself underwater and come back and take off again. Remember, these are autonomous vehicles. So we have, again, 5 patents pending, several related to that vehicle. Specifically related to the size, we'll probably be doing between 50 and 500 pounds, which is perfect for humanitarian aid, inter-island delivery, remote island delivery, expeditionary force. But I've had a lot of examples. We consider this the FedEx because people will tell me Fugro spent $250,000 delivering a small package to a vehicle that was out between Mexico and Hawaii. And we could send an autonomous vehicle out there with that package for them and save them, let's just say, a lot of money. So we're not quite sure what that's going to cost. This vehicle is TR level 8. The other vehicle is like TR level 5. But we've got, the technology. We're just now beginning to scale that up.
Anyone else? All right, well, oh yeah, please, thank you. He doesn't have eyes in the back of his head.
Just a quick question to Egon. You mentioned marine minerals and your surveys. Can you also do simple samples? Because most of these modules are laying on the sea floor, or how do you do it? Can you elaborate a little bit on that?
Yeah, sure. The AUVs that we're deploying in the seabed mineral space, they're really there for exploration phase. So they'll fly up above the seabed and characterize the environment, the marine life. You can do that with the cameras, but the EM sensors and the transmitters are relevant there for exciting a field in the mineral deposits and then getting that back and understanding what kind of it's used for delineation of the mineral deposits there. In terms of samples, I mean that is the next step because these companies want to understand where the minerals are and then go and sample them, and typically that's done with an ROV, certainly not an AUV. So that's one reason behind us acquiring that vessel, which is ROV capable, so we can do that. And we are working with partners who have the ROV and sampling coring capability, but don't have the AUV capability. So there's a combination of different ways we can address that. But you're right. So the exploration phase involves both the surveying and the sampling.
Matt?
Okay. I have 8 seconds. Okay. Well, first of all, thank you very much for presenting. I really appreciate it. I kind of start with a little bit of an anecdote here just to kind of ask the question, I guess, is that one of our members, when I first went to ask them like what they were doing and like what their technology was, really got into the depths of the technology. And it was quite over my head. I'm not saying it's the same thing in this case, but what it kind of showed me is that, what is it that your technology can really do? I said, oh, okay, Thank you for helping us to refocus. So like say if you've got the Hubble satellite or the Hubble telescope, it has all these wonderful technologies, but what does it allow you to do? Well, it allows us to see galaxies. And what does that allow you to do? Well, it allows us to measure this. And it kind of creates a sense of wonder and what these things actually lead in terms of real benefits, like throughout the value chain of benefits for people. So on the end side of that value chain is like, how is it making life better for people, right? So I kind of wanted to ask, how does it make life better for people? Like, how does the technology enable that, especially where it concerns the offshore renewable energy sector? And just the robots and sensors aspect leading towards, the ultimate benefits of, why is it serving humanity and BlueTech and sustainability? I hope that makes sense. It's kind of an abstract question, but that's the one I have.
Well, I'll have a crack at a very practical scenario relevant to what we've been talking about a lot today, which is the floating offshore wind in California. The depths there go from 300 meters to 1,300 meters. So unlike the East Coast, where it's very suitable for surface surveying, that environment is not suitable for surface surveying to collect the quality and resolution of data that you need. You really need to get the sensors down near the sea floor. And you're going to do that with an AUV. And you've got to have the depth rating of an AUV. It's got to have the endurance. And I'd also add there, it's one thing collecting the data, but you've got to then make sure that you process that data properly in a timely fashion, which makes sense to the client, and not ages later. And so the final data deliverable product is a huge part of providing that service as well.
Hey, if I could add an anecdote along those lines, because we didn't have an aerial company here to talk about aerial surveys. We didn't have an ROV company here, other than I could have talked about it, remotely operated vehicles to talk about those bottom surveys. But once upon a time, I worked at Teledyne with that ragtag crew right there in the front center table, particularly Shayan, and we took an unmanned surface vessel with LiDAR on it and side scan, and a remotely operated vehicle with multi-beam sonar and cameras, and a Gavia AUV, and all these things were portable by 1 to 2 people. And we spent 9 days in a different country, and we surveyed all the riprap on the beach, all the waterways, all the way out to the center of the channel, the entire pier, above and below the waterline, and then it was all stitched together into one giant image. And it wasn't perfect, but it was really cool because I don't think anybody had done it before. And Teledyne has the capability to do that because they offer all those technologies other than aerial vehicles, unless something happened last week I didn't hear about yet. But so that's what I see. I see a marriage of unmanned systems with the proper sensors working in synchrony. And it's been done in the past, but it really needs to be worked on and perfected and made real time. But just giving you that whole picture from the tip of the turbine blade all the way down to the bottom with something that's maybe has some supervisory controls. It doesn't have to have full autonomy. So anyways, that's my perspective on the future.
Just to tackle a little bit from our side, just take the DRIX for example, right? And the example that I showed of the wind farm survey. So there's definitely a couple of benefits to having a platform like that operating in a wind farm. One, you're reducing the number of humans you have to send out there in difficult conditions. You saw the sea states were like 2, 3. Not great, but just not necessary. Second, you're able to send these vehicles much closer than you could a manned vessel or a crewed vessel. They can go within 20 meters. It's a very stable platform, so the data quality that you get is extremely high quality, so it reduces post-processing. It's easy to deploy, so there's cost savings almost in every corner because it's really time in terms of deployment, in terms of operation, in terms of efficiency, and also in terms of on the back end when you have to actually deliver the data to the client. The data quality has to meet the standards. So the reason why I talked about the data quality is because that's a direct feedback that we got from our client, because the post-processing was reduced by a factor of 5, they said. So that's a huge saving. So it's safety, efficiency, cost savings, really. So that's just talking about the vehicle. On the sensor side, and I see there are some partners and clients who use some of our sensor technology. It's the reliability of the navigation system. It's durable, it's accurate. So those things matter when you're 6,000 meters below the water depth. It has to work, it has to survive, it has to live, and it has to give you the type of data quality that you need. So it's depending on the sensor or the platform, those are some of the real world benefits that eventually come out.
So we're a sailing vessel, and there's nothing cleaner than sailing because you're using wind. If you use wind, whether it's on land or offshore, by the time it's transmitted and then it's turned into something, it's gone through a number of stages. And by the time it gets to, let's say it becomes ammonia or hydrogen and goes on a vessel, it's not 100% efficient. I mean, there's a lot of efficiency lost along the way. It's not to say we shouldn't do that versus hydrocarbons, but there's nothing more efficient than directly using wind. So from my point of view, the advantage is we're going back to the age of wind, and we're using solar. So we're 100% energy sufficient right at that moment, no hydrocarbons involved. The second thing is by going underwater, we can look at things above water and below water, and we really need to understand the weather and what's going on in the water column and what's going on with the fish stocks, et cetera. And so having vehicles at an affordable price that can do both those things is, we think, very important for humanity. And the third thing is that we are trying to make this affordable enough so that every marine institute in the world can afford one. I think we've had a tendency to build the few and the exquisite, and our goal is to make the many, the agile, the affordable. So that's really what we're trying to do in order to allow people all across the world to be able to gather the information they need, whether it's weather or fisheries, et cetera.
Okay, any more questions? Are people getting thirsty? All right, well, listen, it's a great panel. Dave, always good. Shayan, nice to meet you. Michael Jones. I counted 60 people while they were talking, so I'm pretty impressed. It's after 5 o'clock, and we have 60 people in here, so thank you so much for making our panel worthwhile. Appreciate it.